All right. Well, good morning, everyone. Thank you very much for joining us. Yeah, as Anika said, this is the first time that I've ever done a webinar type thing. I'm not by nature a computery person, so if it's not as smooth as you might have hoped for, my apologies. As Anika said, do jump in questions at the end of each section. So we've broken down into case study, sort of a couple of overall points and some examples of very bad work that was sent by a very good friend of mine, which he kindly allowed me to use in the presentation. So yeah, let's crack on. So a little bit of my background is I've worked in this kind of construction for the last 8 years. The guy who trained me has referred to me as a sort of native in this area because I've never worked on a build which isn't an energy efficient one. So there are certain things when I've done work in the past as a handyman, and I've got, oh my God, why is there a massive hole around that pipe? Because to me, it's just, why would you do that? Although to a lot of people, it may not seem the case. So I've worked on new build and retrofit. I have a preference for retrofit just because it's a lot more interesting. It is a lot more difficult and it's slightly harder to make money on, but it's a fascinating thing to do. So yeah, I've worked from a labourer up to being like a consultant. I've worked on the architect side, builder side. I've got pretty broad understanding of how the construction industry works, or in some cases doesn't work. I'm a trustee of the Association of Environment Conscious Building, which I don't know if you'd know about, but it's been going for 30 years, and it's just based on trying to get people to think about, well, making things more energy efficient and work better for the environment. As I put at the bottom, thanks to all of this interest, I am absolutely the most thrilling person that you could ever hope to meet at a party. I don't understand why I have the big circle of people about 10 foot away from me, but oh well. So yeah, we'll move on to the case studies, this is the first one, and this was well, I'll on most of them I'm not naming names, but this one is all out in the open. It's Ernley Close in Manchester. I don't know if anyone's familiar with it, but at the time it was the biggest Enefit project in the UK, possibly in Europe. There was one in, I think, Belgium that was going on at the same time, so it's difficult to say which one was first. It was a social housing project, and that brought its own complications, particularly to do with sort of tenants who were, some of them had, addictions, mental health problems, things like that, and that was something that had to be constantly managed as the project was going on, particularly when people were moved back in. So as I put it, the intention was for the air tightness and installation to be done externally, but that very quickly became apparent that it couldn't be done. We got onto the job sort of while it had been going on for a few months, and they'd experimented with doing one of the properties the way that it was designed, and that got nearly 6 air changes per hour rather than the 1.5 that it or the one air change that it needed to get. So yeah, they needed a big rethink, which was yeah, a bit of an experience for everyone. Which because it was a full redesign on site. Yeah, but as to be said, the main contractor and the housing association were really, really dedicated to making sure that the project worked. The engagement with householders was absolutely superb. They had someone on there full time, like going around the houses, going to people when they'd been moved out. Really, really good company. So yeah, move on to the method of it, which, as I said before, there was a lot of redesigning, a lot of experimenting on site with, in a lot of cases, experiment with drilling holes and putting expanding foam in, finding massive crater-sized holes that no one knew about. Yeah, it's an absolute laugh a minute. We did have to consider separating the units. Originally, there was a hope that we could make the whole building airtight and not really worry about sort of migration of air or heat between the buildings, but that didn't work due to the internal air tightness. Because the work had been going on for 6 months before anyone got involved specifically on the air tightness and insulation side. There was a lot of things that had been covered over by that point, particularly with, they removed the front and rear elevations because it was actually possible to push them over. I tried to find the video of it, but it doesn't appear to be there anymore. of one of the demolition crew actually pushing over an elevation of wall, which was, yeah, absolutely terrifying that people have been living in there for that amount of time. So yeah, masonry walls were all sealed with tape and parge, whereas the timber was done with membrane. Actually connecting the two things together was quite complex, and we couldn't figure out how air was moving around and why there were so many thermal bridges. As a bit of an aside, we found out that the reason for that was that there was a bricklayer who had a bit of beef with the site manager, knew that the houses needed to be airtight, and sort of wanted to annoy the site manager, so just hid a load of stuff and cracked on. So yeah, that was great fun. Fortunately, he wasn't on the site by the time that we got there, although it would have been useful to have known that he'd done that in the first place, because there was weeks and weeks of exploration that we wouldn't have had to done if we'd have known that he was intentionally leaving massive holes in the brickwork. So we did that by regular air leakage testing. We had 2 fans for decompressing. The way that we tended to do it was we had one team going along and doing the work, one team going along testing, and then we would leapfrog and test each other's work. So that worked pretty well as a rule. We held regular weekly toolbox talks for just updates on how the work was going, to give people on-site training. And that meant that we also found through the toolbox talks that there were a few people who had to be, well, moved on to other projects in some cases because they were just completely disengaged with it, which, you know, they were good builders. They just weren't right for doing this kind of scheme. So move on to pictures of air leakage points that these are all ones that we didn't know about and weren't in the original design. So this was a ground floor of one of the upstairs maisonettes. And all of this channel around the edge it actually looked solid. When we first did our air tests, we couldn't detect anything. And it was only when we weren't hitting the targets that we needed to that we started really investigating. And what we did was duct tape along this channel most of the way along, leaving gaps. And the reason that we did that was so that we could sort of increase the airflow in those small areas to assess whether or not it was leaking. Sure enough, it was. So there's a picture of me going along and taping all of that gap up. On this particular property, from memory, this made 0.3 air changes difference to the property. I'm not sure who's familiar with what I'm talking about with air changes, so we should probably go into that. As a very, very simplistic way of putting it, 6 air changes per hour would mean that the air in that property is changed 6 times. So for every hour that you're heating that house, you're heating 6 times the volume of air. Nick will undoubtedly question that, but it's just a simple way of putting it rather than going into all the complicated maths, which, to be honest, I don't get myself. So yeah, more of the hidden holes. This is on the property that we went to that had already had works done to it. So the picture on the left was trunking to the front elevation above where the timber elevation had been put in. And as you can see, there's a sort of a 15mm gap between the plasterboard and the old brickwork. It was presumed to be sealed from above because the roof had all been completely redone, but air absolutely barreled through that. You could actually feel the air when we had without a fan on, and when we did put the fan on, you could feel the air movement from nearly 2 foot away. It was absolutely racing through it. The picture that we've got on the right hand side, that was the electrician was. You know, he was trained in Germany, knew all about air tightness apparently. And so what he did was drilled all of these holes through the properties, put them in random places, even though there was a drawing as to where all this stuff needed to go, and just left. This hole wasn't an isolated incident. This was, if anything, one of the smaller, more gentle holes that he'd put in, and was absolutely adamant he'd not done it. None of his lads had done it. But they're brand new data cables. And he was like, nope, not us. So yeah, we sort of had it against us in just getting people to understand that when they made a hole, there was a problem. We got more holes again. An electrician-related one was, to be fair, none of us had really considered the fact that because this was an internal wall, that there would be air movement within it, but we ended up having to go over every single plug socket in every single property after they've been fitted and parging it with a small amount of sand and cement, putting mastic in around the edges to make sure that there was no cracking, just to get us down to the levels that we needed to be in. Because in some cases you could really feel the air movement. Again, you didn't need a fan in sucking out air for you to feel the drafts. This one on the right hand side was just an example of, again, another supposedly finished property where it was all we did was move a small piece of timber, and basically the plaster had gone up to a piece of timber which had been temporarily put there for some reason, and rather than taking that off, it wasn't even fixed, but rather than taking it off, he just plastered up to it, carried on, and this leak went straight down to, well, you can't really see it on this picture, but you could actually see daylight through that. So it's yeah, quite interesting. This is internal walls, where I don't know how many of you would be familiar with Paramount walls, which are, it's like egg box doors. In the apparently 70s and 80s, this was a big thing for making internal walls. So these were presumed that there'd be no air leakage through them, because obviously they'd have been built after the masonry wall had been built. And while that was true, there was the hole that you can see on the left hand side was not all of them had it, but quite a lot had holes right through to a cavity, which just bled straight through the egg box wall. So the way that we ended up sealing that was, the picture on the right hand side is something that I'm going to come on to in a bit, that we referred to as the stitch. And what we did was drill holes through between the Paramount wall and the existing brick wall and inject it with airtight foam. So we do that at 150mm centres, spray a little bit of foam in, and then we would go back the following day, drill holes between those, and then spray the foam again. The idea being that we could create a continuous ribbon to seal that wall. We use this in a lot of places. I've had many a sleepless night over whether or not this is going to cause damp problems in the future. The jury's out. Different architects have had different views, different builders have had different views, but what I do know is that there has been no evidence of damp so far, so I think we did the right thing. Here is an example of gaps between joists and walls, where initially we didn't take up any of the ceilings or remove any of the ceilings or the floors to the first floor level, like to the bedrooms above the living rooms. And in every case, obviously, we had completely unsealed brickwork, and wherever there was, this is one of the old heating pipes. Wherever we came across a heating pipe, rather than it being drilled through the wall, a section of brick had been removed next to the joist. And in some cases, we had 4 of these going between properties, usually one of them going out of the front or rear elevation as well. And yeah, these were causing huge problems for cold. In some cases, on properties that we got part of the way through finishing, one of the properties had been closed off for a week, and we came back in, and there was actually mold developing below it, and that's how we realised that we needed to really address this area. So what we did was put little bits of Celcon block into the gap, cut the pipe, and then parge over all of that, which we'll see on the next pictures. So yeah, here's what we did to seal the joists. We removed the ceiling from beneath and the floor above so that we could get all around the joists. A decent parge coat was put on in 3 levels. So we had a base scratch coat, a second rough coat, and then the top coat to smooth it off. Because we found after experimenting that if we only did 1 or 2 layers of it, it still leaked quite a lot of air, so we had to build it up quite thick. And then around the edges we used either a airtight tape or an airtight mastic, dependent on what sort of gap we had between the two, and in some cases dependent on how much time we actually had to address each property, because by this point things were running quite behind, so everyone was under the cosh to get things going, because there was EU funding, which is, obviously in the next few years, EU funding isn't going to be something that anyone's going to have to worry about for programming. But yeah, so we had to go along, sealing everything up, and this was in every single property. In some cases, as you can see from the one on the left, that had actually been re-wallpapered. So that wallpaper had been on for 4 days before it had to be stripped off again. And the site manager was pretty upset about that. Yeah, here's more pictures of the seals to the joists, just so you've got an idea of exactly how we went about it. This was quite labour intensive and took, in some cases, it was like for between 5 and 10 minutes per joist for taping them up. In some cases, it was because the plasterers just weren't willing to play ball because they were on a price and just really badly plastered it over. So it was really difficult to get the tape to actually adhere to the parch coat. But that's what happens, particularly if you're on price work. It's, you know, we understood that the plasterers were having difficulty, because if I was getting paid 25 to 50p for going between each joist, I probably wouldn't feel like making it super smooth myself. So yeah, here we move on to the floors, which were done with, I don't know if any of you would be familiar with an insulation called Vacupor, which is a vacuum insulated panel. So the idea is that you can get, basically, rule of thumb, a quarter of the thickness, so 25 mil of Vacupor is equivalent to 100 mil of Kingspan, as a very rough estimate. So because we were raising the floor height, obviously they needed to be raised as minimally as possible. Vacupor, if you can ever get away with using anything else, use something else, because it is a pig to fit, because any small indentation in the floor causes it to burst. We were laying some of the Vacupor coming in the following day, and 2 or 3 of the panels had popped, which meant big delays because we had to get replacement panels. It's not a nice material to lay. Also, we were then covering it with an airtight membrane, obviously to make sure that it didn't leak. But we had sort of constant worries at the back of our mind as to what were we hiding, knowing that these panels could keep popping. But that was the only choice we had. It would appear, though, after people have been in there for 5 years, there's no problem with cold, so that is good news. The soil pipes on the right hand side going right through the existing concrete slab that was very complicated, actually fitting everything together, making a seal on that. But I'll show that on following slides. So here we've got pictures of the trunking, which had been fitted in, and they went straight through between all the properties, connecting everything together. And we just had to keep going along, and isolating these was, well, it was a big job. In some cases, the only thing that we could do was sort of foam them up with, we used fire foam, because we had discussions with the electrician, manufacturers, and no one could really come up with anything. So we had a sort of basic agreement between everybody, including the people who made the cables, that if we put some fire foam in there, it wasn't going to cause any problems with them burning everything down. And again, 5 years on, nothing's burned down. So fingers crossed, that worked pretty well. But here we're coming on to what I was talking about before, the stitch, which was drilling through the walls. The one on the left, this was a wall which was presumed to be solid, but actually had like a finger cavity. So what we did was drill through the first wall until we felt the drill pop, so that we knew that we were into the cavity. And then we sprayed an amount of foam, and what we were doing was going along, spraying into one hole until it displayed in the hole next to it, and going along in that fashion with the aim of getting a seal. The reason that this needed doing was because there was a lot of places that no matter how much we took out of it, we couldn't get to certain areas that we knew were going to be problems. So this was just a way of trying to stop the air getting in at source. So on the right hand side, we did this on all of the staircases because they wanted to keep the original staircases in place. Obviously, behind the stair string, there was quite a gap which had never been plastered, and it was amazing when you had the fan on. You could actually feel air coming out between the treads and risers of the stairs. So we again sprayed the foam down that to create a continuous ribbon up the side of the stair stringer, just to try and stop any air getting through. And in most cases, that worked, although we were still having some problems with air leakage, which I'll come on to again in a minute as to how we address that. So this is another example of us having to do it externally because they had big brick pillars out the fronts of the properties. And this was leaking into our friend Eddie, the bricklayer, who had left all the crater-sized holes where the timber front and rear elevations had gone. Air was getting into them through the ground. So we had to go outside, drill through. And the reason that we put these pegs in is because we got a boroscope in and we found that this was just a big, solid, open hole. So we knew that if we sprayed the foam in, it had plenty of room to expand without potentially causing structural problems. Because expanding foam, it's amazing the damage that it can do by pushing old brickwork out, particularly if you've got your old dusty lime mortar. It can actually push the bricks out. So that was something that we had to be constantly in mind of. But yeah, in this case, we put the pegs in so that we could hope that the foam would fill all of the bottom of the pillar. And it seems to have done. Yeah, so this is to go back to the internal soil pipes. We had big problems with plasterers. You're obviously the one on the left-hand side. How do you get a trowel into that? So we had the plasterer called Tom who was going along and he had rubber gloves on and he was daubing plaster down this. Nowadays, there is an airtight paint that you can get, which would have made things easy. But that started coming into existence towards the tail end of this job. So nowadays, what we had on the left wouldn't have been a big issue because you'd have just been able to paint it up. The right-hand side, because it was the existing soil pipes, they were right tight into the corners of all the properties. So what we had to do was pour a really weak slurry mix down into the hole and hope that that sealed up. And then again, rubber gloves, bit of mastic on our fingertips. We're going behind and squeezing it in wherever we could to try and seal that up. Yeah, this is all the complications of retrofits. Basically, if you can get rid of an internal soil pipe, get rid of it, move it external, because there's also problems with cold bridging, because obviously that is just a big pipe of air running through all of your insulation layers. So when I was saying on the staircase about us finding leaks even after we'd done the stitch, this was the reason. Absolutely no one had considered that under the staircase there was a big panelled off area and behind it more unsealed brickwork. So we found the skinniest of the plasterers and it was his job to go along every single staircase of these 32 flats and do this little triangle of plastering. He didn't like that, poor lad. So the lessons that we learned from doing this job was that coming up with a new design for airtightness it's slow and costly. The best thing that you can do is just stop the work, go back to the drawing board and work through your designs. If you've got these sorts of problems, don't crack on and think that everything will work out, because while in this case it did, it worked out because everybody was really invested, and while there wasn't a limitless supply of funds, they wanted to make it work and they could afford to put it in. So all of these flats, 32 of them, were supposedly identical. That wasn't the case. There was we joked about ones that had been built on a Friday, where certain bricks had been left out, certain joists had been put in at really cob angles. So not every single one could have the same things done to it. We had a whole list of extra measures that we had to employ if we weren't hitting the rate for air changes. The thing that we learned is that for projects of more than 2 or 3 houses, you need a dedicated team for doing this. Even if it's subcontracted out work for the insulation, that doesn't matter. You need someone on your own team going along and making sure that that work's done correctly. Not everyone can be everywhere at once. If the work is being run on price, then people are going to cut corners here and there. Hopefully, most of the team aren't, but we all know on price work, there will be someone who cuts corners, and you just need to make sure that that doesn't happen. As I was saying with the toolbox talks, there are a lot of builders who are just completely uninterested in that. Like if I'd have had a quid for every time that someone has said, "Oh, I think this is a load of bollocks. All houses are meant to breathe. I don't see why you bother doing all of this." Well, I wouldn't need to have a job anymore. So yeah, that's. Does anyone have any questions about that? About anything?
Sorry for that. Can you hear me now?
Can hear you now, yes.
Yeah. I was just saying, if we could take that maybe 1 or 2 questions, and then anyone.
Can I ask one?
Yes.
It's Nick. Liam, when those data cables that you showed us, which were going through that rather generous hole, which weren't done by the electrician apparently, did you have to take them out and grommet them, or how did you deal with them?
We were completely unable to take them out because they'd all been fitted in pretty much first job on the site.
Yeah.
So what we were doing was we got these, I can't remember what they're called, but they're little plastic separator clips. So we had to go and separate the 2 cables out with a cable clip.
Yeah.
That hole was then sort of, we tried to put a wheat mix of sand and cement into those holes.
Yeah.
And then once that had gone off, we were sealing round the cables with Orcon F, which is, to people who don't know, an airtight mastic.
Yeah.
Because then we felt fairly secure doing that because those cables had all been clipped left, right, and centre. They weren't going to get moved as the job went on. So it wasn't ideal, and we would have liked to have removed the cables and started again, but time was against us.
Well, it's just, grommeting, if you haven't done it first time, you're going to cut everything and have to reconnect and so on if you're going to do it again. So yeah, it's good that you found an alternative to that.
Yeah, I mean, it's something that I found on a lot of jobs is if the runs for all of the pipe work, the electrics haven't been set up in advance, drawn on the walls as to where they're going, so the holes can be drilled through and the grommet put on in the first place. You don't get the opportunity because people on a price tend to get very upset about people getting under the thing. Oh, sorry, 2 minutes, mate. Let me just stop you doing your job.
So we've got another question from Will, and then we should probably move on because I think we're a bit behind.
Hello, everyone. Can you hear me?
Yes.
Yes.
Yeah. Okay. I'm enjoying this very much. Thank you for doing this. I have to declare an interest because we're already a supplier to the Carbon Co-op and various others. So we sell building materials, and looking at what you're doing, how long ago were the maisonettes? That was a couple of years ago, did you say?
This would be coming up 6 years ago now.
Okay, so you mentioned a couple of products that we sell, which we know are typically used in these kind of scenarios, and the horror scenario that you were explaining to us there are actually some very simple ways of solving those problems now with products that weren't available when you took the pictures. I'd just start by just picking up on a few of the things that you said, which I think we see people using on a regular basis to solve similar problems. I think the first thing I'd say is it's always worth noting what things are not airtight. Generally speaking, one would presume that PU foam and mastics are not airtight unless they're specifically designed to be so. So the foam you used, I noticed, was Tremco FM330, which is a certified airtight foam. The reason people don't use it is it costs about 12 quid for a canister, whereas Bogo standard foam costs about 3 quid. Guess what people use? Again, you mentioned a liquid applied membrane. The question about the grommets, a simple cheap as chips non-shrink cementitious mortar to plug the bulk of the hole will leave you with small enough gaps to use a paint-on fiber reinforced airtight membrane, which is so much easier. It might look a bit messy, but it will do the job. And you can also plaster over it, which again allows you to create a finished surface. Other products I'd very quickly mention, Marmox MSP 360. Again, that is a genuine sealant rather than just an adhesive like you mentioned Orcon F. But there are some really handy things for when you come across what were you thinking of type scenarios, which you've just illustrated to us. But I would say again, under the stairwell, for example, you could use a tape as well to seal the connections. Like there's a tape called Proclima Solido, which is a plaster-in tape. You might need a primer, but there are a small number of products that would really help when people encounter that kind of scenario.
Yeah. No, you're quite right, but you're putting in quite a lot of spoilers for the rest of the presentation.
Oh, am I? I do beg your pardon.
Maybe we'll move
Why
on.
don't I just shut up then? And then...
Well, I wouldn't use those words as such.
Maybe it'd be a good idea to move on. We've got half an hour left, just so you know, Liam. So you might not be able
Half
to...
an hour? Crikey O'Reilly. Doesn't time fly when you're having fun?
Yeah, I was messaging you privately saying, come on now, but yeah, I don't
Oh,
think...
right, sorry. Yeah, right. Anyway, I'll crack on. Speed up.
You
Right.
might need to just think about whether you go through all of it or whether you just prioritise.
Yeah. Right, I'll race through. Right,
Just a
this.
sec. I'm going to just mute everyone and then unmute you.
Yep, no.
Okay, there you go.
Yep. Right, well, this was a big project, 3 houses all in one, which had barns in it, everything like that. So fairly complicated figuring out. Originally, it was meant to get to AECB standard, which is simply a building standard for energy efficient houses, for those who don't know. It had a full survey commission, but it turned out it wasn't great at finding absolutely anything. It had an MVHR installed, but because of the result it got, actually a simpler ventilation system could have been installed. I would have gone into something there, but let's not. So complications were, because it was 3 properties, there was a lot of stuff that wasn't included in the retrofit work, which meant that connections were very difficult. A lot of features were to be retained, so we couldn't carry out the investigation work that would have been necessary to get to those levels. Householders stayed in it. As a big thing to say, if you're doing a big retrofit, the householders can't stay. It's costing them money. Like you can't do the work the speed that you need to. So the budget was swallowed up with repair work because the survey was just not there. We had to run it on a small team and they just got burned out really quickly because we couldn't sequence in getting any subcontractors, and it tired everyone out. So got onto the insulation method. So we did a combination insulated timber floor, insulated concrete slab, timber floor over a concrete slab. There were sections of it that couldn't be insulated because it was like a parquet floor, things like that. These areas are noticeably colder than other areas of the house because they couldn't be insulated. So this is something that everyone will have seen before, just the way to do a insulated concrete slab with the upstands to make sure that you can connect to any insulation that goes above, particularly internal wall insulation. So this is the floor insulation over an existing concrete slab where we put timbers in. Again, just used the standard jab light. The room that this is actually the room that I'm in now, and it's nice and warm. Timber suspended floor insulation. This was the prep work. We had to, Ecological Building Systems had a system where you set up cavity trays to hold the insulation. I have to say I'm not convinced by this method. Actually, timber suspended floor insulation in general, better off putting in a concrete slab if you can get away with it. There's a lot of problems, potential problems that you aren't going to get. But anyway, this was a big job. So this was more examples where we were connecting through to where there were pipes. We had to put membranes in to seal it up. Big job. The insulation is a jute natural insulation, and it's really lovely to work with, provided you've got a dust mask on, because the fibres get everywhere, and I mean everywhere. So here's a picture of Sol laying some of the channels while I'm going behind insulating. Went quite well. Nice and warm in there now. So the roof insulation was earthwall between rafters, which meant that we had to underdraw it with additional timbers so that we could get the thickness of insulation needed, and rigid insulation in some cases where there was no head height and we couldn't underdraw. It was important that we had a ventilation gap because it wasn't re-roofed, so there was an impermeable felt underneath, which really makes things quite a bit more difficult. If you can get a re-roof into the job, get a re-roof in. So this is an example of where there was minimal head height. We used Celotex, sealed it all up, and then put an Intello airtight membrane over that, then a service void plasterboard. This is an example of one of the cathedral ceilings, which we did with earth wool. This is as it was going on, so all the gaps were sealed up. We had to put two layers in, and generally we'd come back in the morning and half of it had fallen out, but that's the joy of using soft insulation in a roof space. The air tightness layer was this vapor block board, which is cracking stuff. Like it weighs a ton getting it up there. It's nigh on equivalent to fire plasterboard. But it improved racking strength when you're going along through the rafters. So it's good in that situation. So the internal wall insulation was all Gutex wood fibre board. I'm a big fan of wood fibre boards. Just they're nice to work with. They're vapor permeable. They're generally good stuff, but you do have to strip all the wallpaper, all the wall finishes off, because otherwise you can have problems with condensation, damp, things like that, and mold. So yeah, they need a lot of repair, which we got through. Took a long time, but that's what happened. Buried cables absolutely everywhere. Cables to nowhere that have been wrapped in insulation tape. We all got electrocuted at least once. Super top fun. Here's examples of the wood fibre insulation in place. There are other ones which tooth together. This one is adhesive onto the walls, which I prefer to the pegging, just because it means that you've got minimal chance of thermal bypass, provided you can get all the adhesive on as a solid backing. That's just another picture of it. So yeah, the external wall insulation was rendered XPS. We had to put extensions onto the roof with aluminium coping. So there's one of them that you can get, which is an extended gutter, which is pretty good, but very difficult to fit, and seemingly you just leaks, and is really difficult to fix up. So it's good, and apparently they've improved it since this one was fitted. So yeah, have a look at that. It's a mixture of brick slips and render. And yeah, looks pretty good. Looks like the house did in the first place. Yeah, that was meant to have a picture of the render on. Let's gloss over that. I've not done it. Sorry. So, lessons learned from this job. Don't go along with a budget that you know isn't high enough, because he had a very minimal budget. And we're like, oh, God, it's a bit tight. Knowing full well there'd be extra work that needed to be doing. Sure enough, there was. Budget was non-existent. Old farmhouses with different floor levels, different build phases, don't want to be insulated and airtight. You've got your work cut out. Not saying don't do it, but do consider what's actually possible. Don't continue work without an agreement in the change of scope. For example, if you realise that you've got to make alterations, if the architect hasn't agreed it in writing, do not crack on. Just because a project is interesting, which was why we took on this job, because it was the most interesting job I'd ever seen, it doesn't mean that you should make sacrifices cost-wise to try and make sure that you get the work. We made a mistake there, and it caused us untold woes. Yeah, make sure that people move out. Do not do a retrofit with people living in the house. Everyone will hate it. You will all have a very, very sad time. So yeah, that's that one. I think we should probably crack on, given the amount of time, if that's all right.
I think you whipped through that. and so that, if anyone does have a question at this point before moving on, I think we do have a couple of minutes for a question. Maybe somebody's not asked a question before. If anyone wants to raise their hand or just unmute themselves.
Can I ask one again?
Can I check if there's anyone else first?
Yes, of course. Yeah.
Just give them another minute if there's anyone else.
I haven't worked out how to raise my hand.
Okay, go for it.
Like that.
Okay, just out of interest, Liam, why XPS, extruded polystyrene, which is completely vapor closed on the EWI?
Ask me one on sport.
Okay, next question.
That's what the architect specified.
Okay, fine.
All right.
Okay, maybe we can go on. Go for it.
Right, I've got a different pace for this one. Let's try somewhere in between. So yeah, this is there might be people here who are familiar with this one. It's a one-off retrofit project near Manchester. Began as just a standard deep retrofit, see how far it could go. Moved to AECB building standard. Don't know where it actually ended up. The original main contractor went into liquidation, which caused a bit of grief for the contractor who took over. The project was already delayed when the new guy started work, which again probably caused a few complications. The architect and the new contractor were pretty inexperienced in deep retrofit, so it was a really steep learning curve for everyone involved. So the method was EWI to the existing structure, rigid cavity wall insulation to the extension. As a bit of an aside, I'm dead set against using rigid cavity wall insulation, not for anything to do with U value or anything like that, just because it's impossible to actually connect it together. Like it makes perfect sense. It's got a very high U value in theory, but in practice, you can never hope to achieve that because you're going to have gaps. There is nothing that you can do to stop that happening. Or maybe there is, but versus just using an insulation which naturally closes itself up. I just don't think that rigid cavity wall insulation should be done. Nick might want to say something afterwards about more reasoning, but we'll see if we've got time. So the air tightness layer on it was almost exclusively membrane, except for the internal walls, which received a parge coat. We'll talk about that in more detail in a bit, but that's a fairly interesting way of doing the air tightness on a masonry build. Ventilation was a full MVHR with plastic ducts. Again, come on to that shortly. The big extension was, it was a really complicated shape for, if you're doing any sort of energy efficient construction, try and make the shape of the build as simple as possible. Like that's just the easiest way to go about it. So there was a lot of thermal bridges in connecting between the existing and the new extension. The ground floor to the existing house was insulated timber suspended, and the extension had an insulated block and beam. Again, come on to that in a minute. So the installation of the measures on the left-hand side, this is the Intello membrane on the ceiling going to one of the internal walls, which is going to get parged up. On the right-hand side, this is an example of where the stud work was built off the gable wall so that we could feed the membrane behind it. So just to try and make the air tightness as easy as we could. So the way that we did it was, when we made the ceiling airtight, taped all along the perimeter of the walls to try and separate the loft space from the walls, because with this kind of thing, there's a big risk of thermal bypass, air ingress getting behind and, well, causing problems with thermal integrity. So what we did with the stud work that was put over the membranes was they were fixed top and bottom, and then it was held in place by little plastic packers going behind, held in with foam with ventilation space, so that we hopefully minimized any risk of condensation, to try and stop, so that the wall didn't push back. Seemed to work okay. So we did, as I say, the air tightness, the full membrane. There's a lot of pros and cons to this. The pros are, it's fairly easy to guarantee an airtight seal because you can actually see where the air tightness has happened. This is, in my opinion anyway. It's pretty obvious where the air tightness has been completed and where it's not. If you're using parge, if you don't know, you can't tell whether it's had 2 coats or 3 coats. The envelope can be completed by one responsible person. You're not reliant on multiple trades and sort of juggling them and making sure that the work's gone the way that it should have. The cons of it are that it's very fiddly to connect it together, particularly here where you can see where it's had to go around the joists. That was a nuisance of a thing to do. It's quite an expensive option, just based in the sheer labour cost and also the way that it slows down other people on site. A big opportunity for thermal bypass, as we're saying, behind the membrane, which can hinder the insulation performance. So we'll move on now. Underfloor insulation, which is a pretty complicated spec, because we had to insulate the dwarf walls. I still question why it needed dwarf walls, but anyway, by the by. So we had to put brick vents in. There was, we all thought throughout it, the original contractor, new contractor, we all thought that it should have just had a new concrete slab. There was no reason for it not to, but the structural engineers thought that there might be a problem with heave. But that's not for me to question, really. Here's the way that the underfloor insulation was done. It was, like I say, quite a laborious and fiddly job, and also it took a long time for the decision to be made as to how we went about this. So it caused big delays because a lot of other work couldn't go on until this had been completed. Here's some pictures of the MVHR ducts, they went in and out of the thermal envelope like quite a lot, and there was a lot of work needed to try and address those issues, particularly up in the loft space where it was a very tight area. So actually getting membranes behind, making sure that the seals were done, was a big job. So yeah, the duct runs just made things really complicated. In some cases, they were running through stud walls where there wasn't quite enough space for them, which I imagine would have caused a bit of grief for people who were doing it, like actually fixing plasterboard on afterwards. The installer was not great, not terribly good at communication, and the designs were altered on site, and that causes big problems because you can't plan where you're going to go, where you need to be for sealing everything up if plans are changing while you're doing the work. So yeah, I've already addressed the penetrations of the airtight layer and the insulation, but yeah, so that meant extra work for all of us on the job. Yeah, this is just an example of really tight spacing before the airtightness had been done. So that was just a nuisance to seal up, getting back behind the steel, everything like that. I'm personally not a big fan of this plastic tubing because, to my mind, having like really tight turns like you've got on the right hand side, airflow is not going to be great if it's got to go round a big twisty route. So I personally prefer the aluminium spiralized ones. So yeah, complications. The scope of works was clear in theory, but there was a lot of decisions while the job was going on, which just led to delays and extra costs. There was so many things which like, yeah, we'll have a decision. Decision didn't come until the hand was forced. The client did make some alterations, mostly to finishes, but when you're on a tight schedule that's already running behind, clients often don't see that their changes are causing the problem that they have with a delay, which is that's just the thing. That's not special to retrofit. That's just building in general and some clients. So the sequencing of the EWI and the window installation, well, the big problem with liquidations on this job, I think, because the window company also went into liquidation, and that was a really good example of yeah, they'll be with you next week. They'll be with you next week. They'll be with you next week. EWI, it was impossible for the main contractor to get the EWI people onto the site because no one knew when it was going to be able to be booked in. So that caused big delays. Yeah, still, let's go on to the positives, which is the main contractor was very eager to do the works correctly, carrying them out to a very high standard. I have never ever worked on a job before where an inexperienced team have actually listened to stuff to do with air tightness and done the work properly and asked questions and protected the airtight layer. And like, I've never worked on a job where the builders have been that engaged. So to people who were involved in this job, if you can figure it out, good work. You're absolutely brilliant. The architect was inexperienced, but he had specialist support to help make sure the design was right. That did cause delays, but it also meant that at least when decisions were getting made, it was a good decision. So the external specialist for carrying out air tightness, I was a hangover from being employed by the previous building company and was taken on by the householder. But I'd like to think that it helped all of us on the job, but that's for those who were involved to decide. And as far as I know, it achieved the desired results. So everyone can be proud of what happened there. Oh yeah, that's the end of that one. If anyone's got any questions?
Or comments about your
More comments?
job? Yeah. Yeah. John has a question, so I'll just unmute him. Hi, John.
Hi, Anika and Liam. Hi, Liam. Is it possible we could get a list of the products that you mentioned in the the tightness products, because you seem to whisk them quite quickly, and I'm not familiar with them. So I just wonder if it's helpful if we get like a list at the at some point of list of products used in air tightness.
Yeah, I mean, I would imagine that there are a great many suppliers like Eco Merchant, Green Building Store, Ecological Building Systems would probably be the best people to actually give you that breakdown, because as Will quite rightly said, things are constantly changing. New products are coming out all the time. Even since I stopped working on building sites in October, I know that there are new products that have come out. So Will would probably be the best person to talk to about that.
Maybe for now, as we've got 10 minutes left, Will, if you don't mind just putting any comments into the chat box for now, and then we'll have questions at the end as well. That's okay. I can see that you've got your hand up, but maybe it's time for us to move on to the last section. That's okay.
Yeah, that's fine by me. So this is, well, some of the pictures are from my friend who kindly has allowed me to use them, but this is just some examples of what really bad work looks like. So first one is one that I think a lot of people will be familiar. This is a job in Preston to do with external wall insulation, and I don't think it needs any explanation as to why that might be a bad job. Just, yeah, really, really appalling, terrible cases of mold, because obviously what I can get behind, but just really, really badly planned out and installed. This is the ones that my friend Paul has allowed me to use, which is air tightness done badly. This was actually deemed ready for a proper air tightness test where you get the numbers and whether you find out whether it's a pass or a fail. Well, I don't know if it might be quite tricky to see where the problems are here. Yeah, and this is, I have to say, this is a fairly common thing that people think, well, I've put a load of membrane on, so obviously it's airtight. Yeah, I've got a little gap, but look at how much of the wall I've covered over. I was like, that's not really how it works. If you haven't sealed the envelope, and the same goes for insulation, if you haven't connected everything together, you haven't made sure there's no gaps, you haven't got an insulated envelope, you haven't got an airtight envelope, you've got something which probably down the line is going to cause you severe damp and mold issues. Is some which, I mean, I thought they were particularly interesting because the one on the right hand side in particular, that's a very similar method to what was used in the extension section of the third case study. But that was what they deemed acceptable as an airtight layer, sticking a bit of foam between the rigid boards, and it's just, well, it didn't. It leaked absolutely everywhere like a sieve. The picture on the left-hand side was, again, that, I mean, I personally, I'd have put a membrane, I'd have insulated that and put a membrane over. I'm not sure, I don't know enough about it to know whether that would have been the right thing, but that's certainly my opinion. Yeah, bad. Is a connection which people who worked on case study 3 might remember us spending a lot of time figuring out about drilling through timbers, like to make a little hole so that we could inject it with spray foam or Orcon F to get rid of the joint between the two timbers. So yeah, that's just an example of one that had been left and they just hadn't considered that air can move between two timbers. On the right hand side, that is an example of incoming, or probably a soil pipe, and that needs sort of, well, probably a grommet going over it, which would just seal it completely. And with this, it's when Nick mentioned before about the complications of putting on grommets. With something like this, you've got acres of time to put a grommet on. There is absolutely no reason why this wouldn't have a grommet. So it was just poor workmanship. This is, again, another 2 examples around a window reveal where I can't understand how you would get to this, how you would not extend and realize that it all needed jointing together. Sorry, I'm going to get a bit ranty about this. I just can't believe that people are capable of doing such an appalling job. It's like you don't need to know the first thing about air tightness to know that the 2 bits of it have probably got to join together. But
Liam, do you mean the blue bit of membrane and the tape?
So yes,
together.
Yeah. That's what I mean, because the membrane is completely unconnected to anything. So any air that's meant to be getting stopped by the membrane is still going to come out. And it don't matter that they've put tape from the window back to the timber, because while that might stop air coming through from the window, I mean, it won't because of the metal bracket. But yeah, it's just poor. Is all I can say about that. So yeah, that's examples of work done badly. Just to summarise on everything that we've gone through today, sorry if it's been a bit up and down, speeding up and slowing down. I'm getting to grips with how a webinar works, and it's quite weird just having like a thumbnail of people who occasionally swap round for some reason on the right hand side. So yeah, sorry about that. The summary though is what are the usual complications on a retrofit project. So you can see these are all things that we spoke about. Is poor forward planning, which means that people will just get onto a job and go, well, we can figure out these things as we go along. If it's a retrofit, that might be true, but it's going to cost everybody involved a load of money and a load of time, and it's going to cause grief. When I say loose grasp of the aims, I mean, to go back to the job done badly. People think, well, I've put a load of membrane on, so that'll be fine. It don't matter if a few joints haven't been taped. Look at all I've sealed up. That's misunderstanding the point. Communication. I mean, communication is a key in absolutely any walk of life, but particularly with a retrofit, you haven't got anywhere to hide. You can't just go along in your little silo thinking, well, I'm doing my job right. It doesn't matter, because that will come along and bite you in the arse anyway, because someone will come along and go, actually, no, you haven't done it right. And yeah, it will cause problems. Scope and budget being left unclear is a really common thing, particularly if it's not an architect-led design. If it's just someone coming in and saying, right, I want this floor insulated, you go along, insulate the floor. Actually, I think I'll have this wall insulated. Yep, that's fine. And then they go, oh, well, actually, I've had a kitchen fitted. I need something done. Well, no, you can't. You've had a kitchen fitted now. You need the kitchen removing. It's really important to work through the aims. But as we do at Carbon Court, where we have the My Home Energy Planner, which is to come up with the different aims in a whole house way, so that if someone can only do one measure for now, don't matter if they can only do that one measure for now, they know that every measure that they install in future is going to improve things, is going to be able to be connected together. And that's a really important thing to work through with a householder. Changing plans partway through is, again, not exclusive to retrofit, it's what happens. But it's really, really important that when you've got a plan, it's stuck to. And if it isn't stuck to, there's a bloody good reason why it isn't being stuck to. A lot of people as well with not doing a proper induction, not doing toolbox talks, not carrying out on-site training. It's really, really important. Even if everyone knows what they're doing, even if everyone has worked on these kind of projects before, just once a week having maybe a 10-minute chat about where people have been, what people have done, what you're intending on doing this week. It's just really important to all keep on the same page, go over, look at each other's work, basically demonstrate an interest in what other people are doing. That's the way that a retrofit project runs smoothly. Construction is complicated enough. This is a really good diagram of how all the supply chains and everything works. But the point is, I can't make head and tail of it, even though I know that that's how a supply chain works. So we don't need to be making it more complicated. Like, I put in a, don't panic about it. People, a lot of builders, I've done it on projects where you're going, oh my God, what the hell does this mean? Like, well, how are we meant to go about doing this? Just break everything down into its constituent parts. If you can't break it down, if an architect has done a design, it's their job to break it down for you. Go back, ask questions, make sure that you're doing the work correctly, because you can be damn sure if you've misunderstood the drawing, it's still going to be on your toes come the end of it. Take care. I couldn't think of a better example of taking care. Like, just think about the job that you're doing. Spend 5 minutes piecing together what you're going to do, working out the sequence of things before the work goes on, and it'll save you time. It'll save you a lot of time. Simplicity, always simplicity. Architects often have, there's a big thing about on the drawings, detail after detail after detail. Make sure that those details are separated out, even if it's like one section drawing with the different elements on top of it. It can be understood. It's in everyone's interest to make sure that simplicity is the key. Clarity in the design is just more of a follow-on from that. Just make sure that everything's clear. If the job that you are being told to do isn't clear, whether you're the project manager, labourer, whatever level you are, make sure that you are clear about what you're doing. Ask the questions. It's really, really important that you've got everything clear in your head. Otherwise, it becomes stressful and very irritating. Effective sequencing. As I was saying on case study 2, our sequencing was completely out the window because of the complications that we were discovering just because of the fabric of the building. But make sure that you've got your program, you've got your schedule, and keep on top. Even if it alters, keep on top of it. Don't let things get away from you, because in retrofit, if things start getting away from you, it snowballs and it's very difficult to bring it back. Right. So clear communication. This final point on it. Communication is absolute key. This is an example of something that I used in a presentation that I did last year. I had my plasterer mate down a hole. I was thinking, oh, it'd be really nice. I could have a picture of his face, so people knew who he was. So I sent him the message of, "Can you send me a picture of you, please?" Admittedly, maybe I shouldn't have put the case afterwards, but we lived together for many years. It's the relationship that we have. So he sent back, no questions, this picture for my presentation. So I still included it in the presentation, but the point was, I just wanted a picture of his face, but I hadn't communicated that, and admittedly, I'd muddied the water with a kiss. But these things happen. So anyway, that is the end of the presentation. So I think we've got time for some questions if anyone's got any. Thank you for listening to me.
Thanks, Liam. That was really great. There's a few claps, which is brilliant.
Thank you.
Clap function. Has anyone got any questions? Rather than unmuting you all, which I think I might end up with lots of noise, if anyone could put their hand up or just unmute themselves if you'd like to ask a question. Got anyone? Give you another minute in case you're...
I've got a question about the sequencing of the project. I know you've spoken about how you're kind of trying to integrate all this stuff into the design. If there's ever like a time when it's not integrated and you're having to come onto the job, when do you ideally want to be called in to have to deal with sealing and air tightness issues, if it's not already integrated, that is?
Yeah, what if it's not just started that way? Right. Well, the simplest way of putting it is absolutely as soon as possible. Like it's because the more that you go along through the job, if the air tightness hasn't been included or thought about, it's just generally going to mean that if you want to achieve the desired results, you're going to have to remove a lot of the finishes that you've put on. You're going to works that have been done are going to have to be removed so that the air tightness can be done correctly. And you will end up in a situation where you've got a choice of achieving the air tightness aims that you wanted or finishing the job. Like the longer that work continues, the more it becomes a risk that you're just not going to achieve those results because your budget would be swallowed up by removing work to then have to replace it.
Is there possibly an issue that, if you're, say, the first call on a job, then later on down the line, someone's going to muddy the work that you've already put in, and then you're going to have to be called back to fix it? Or is it that you'd continue on the job and keep going whilst other contractors are on site? You think it's better rather than having everything separate? I've
always preferred doing the air tightness work with the other work still going on. People who do air tightness do it in different ways, but I've always preferred, even though it's a bit of a nuisance, like people are on each other's feet a bit. There's a lot of questions, like little questions that get asked that can be sorted out by having the air tightness done while the other works are ongoing. Because I think the risk of some people just have the site completely closed, they're the only ones on for a couple of weeks. I think that has the risk of making the retrofit measures seem like something other, like special, and they shouldn't be special. Individual retrofit measures are not complicated. It's made to seem complicated, and but it's done because it's almost like people are trying to make themselves look more special, and it shouldn't be. A lot of questions are really easy to answer, so you need to be there while the work's ongoing. To come back to your point of having to come back on works afterwards, yes, that is the case. When I've worked as air tightness installer, I tend to run it so that I install all of the air tightness measures, then I have a calibrated leak test done, and at that point, when it has passed at the level that it needs to pass, that's where my invoice is generated, and that's the end of my responsibility. I or anyone else doing the air tightness can't be responsible for what goes on after they've left the job. It's good practice to let people know what's what, give them ideas of what to protect, what's not important, everything like that. And I have had to. There was one job that I had to go back on. I was like, oh, well, it passed at 0.7. It's now at 4. Look, right? Well, what have you done? Well, you've not done anything. I got there, everything was peppered with holes. The plumber completely rechanged the piping system for the heating. I was like, and they're like, well, you need to fix this. This is your problem. I'm like, no, it's not my problem. I've finished my work. Why have you changed all the pipe runs? Well, it's just needed to be done. You need to fix this. Like, no, there's now what we can do about this. If you're not paying me, I'm not fixing it. So yeah, you've got to be a bit mercenary about it. But it's the same with everything, isn't it?
Yeah, that's all from me. Thank you.
All right.
Thanks. Any other questions? Got Will, who's got his hand up. Do you want to ask a question? Also, just say we're 6 minutes over, so I don't know if anyone needs to leave. I'd like to do a quick poll, like a feedback thing, just before we finish. So I'll do that in a few minutes if there's no other questions.
If that's okay.
Yeah.
Liam, thanks for that. And I've sent an email out to everybody. We can deal with lists of materials, etc. But I think you've just almost covered the question I was going to ask, which is about testing. You haven't really mentioned a testing regime, but you can test just by feeling it with the back of your hand or with a smoke detector. But could you just tell everybody about what your normal MO is when it comes to having a building tested? Because the scenarios that you've outlined, if you had an air tightness tester in to sign it off, almost everything you showed us would have failed miserably and require a lot of remedial work. So could you just, Liam, run through what your sort of normal procedure is for testing and whether you do it more than once and when you might do it?
Yeah. And out of interest, which bits do you think would have failed miserably?
Well, what, all of the awful ones that you showed?
Oh God, yeah. Yeah. Well, I've always had an uncalibrated leak testing fan that just quite simply sucks the air out of the property, and you can go around, as Will says, with a smoke. I use incense sticks because they're dirt cheap, and do exactly the same thing as the fancier smoke pencils. I think if you're doing a deep retrofit, the best thing to do is have it tested before any works are done, so you know whether it's going to be achievable. Because if a house has, say, got 15 air changes, no matter what you do, the chances of getting down to one air change, it's stacked against you. So it should be used to inform the decisions as to what retrofit levels are going to be gone to in the first place. You should try and make sure that all of your air tightness and insulation is done before any finishes go in, so everything's exposed. At that point, that's where I do a big leak test with the uncalibrated fan, make sure that I can't find any holes. Then a proper air tester comes in, that's when you get the numbers. If the numbers are what you were hoping for, what the design calls for, then you're golden. You crack on and put your finishes in, and then you have your final acceptance test, which hopefully is, if anything, better than the preliminary one.
Can everyone hear me? I don't know, but there's one other test that's worth doing on a building before you start, and that's having a thermographic survey done. Yeah. That's another good way to highlight it. I can remember a building that we did with Paul from Aldas where he thermographically imaged it, and what looked like a rendered wall that was intact turned out to look like a chessboard because the mortar between the blocks underneath was so poor that it was leaking. Yeah. And it was one of the main causes on the building, but it wasn't visible to the naked eye. No. So I'm with you on this one. I think that testing is the way to benchmark the security of the air tightness. And I would go along with you and recommend that you test it more than once in various different ways.
Yeah, I mean, because the reason that I didn't really go into that in any much detail is because this was meant to be for builders, and to my mind, that's a designer and specifier thing.
Great. So we're towards the end now. I've got a quick poll, if you wouldn't mind. I think Liam's going to put it up on screen. It's just
Yes.
a sort of quick thing to just say how you found this session.
Launch polling.
So if you don't mind filling that out, and then if you wouldn't mind using the Zoom chat, hopefully everyone's seen it and knows how to access it. If you could just write in there one thing that you found positive about the session, one thing that you didn't find that great, and then one suggestion you have, that will be super helpful for us in terms of improving how we do these things, because we're planning to do some more of these over the next few months, but we're just learning how to use this sort of format and technique. So your feedback's super helpful. So I don't know if you've managed to send the poll, Liam.
Yeah, I've sent it out. It's been going for 36 seconds.
Okay, can people see the poll?
Yeah.
Little nods. Yeah, we've got a thumbs up. Brilliant. So if you could fill the poll out and then use the Zoom chat. And if you'd rather leave anonymous feedback, I can send you out a survey link instead. But I thought this might be an easier way to just get people's quick comments now.
Yeah, I really enjoyed that, Liam. Thanks for that. I have actually got a possible project I was going to speak to you about. I just wondered if you've got any time just to speak one-on-one.
Yeah, can we, am I all right giving you a call in a bit?
Yeah,
Like,
no problem.
If that's all right. Yeah, great.
Yeah, that's fine.
Yeah, well, like, I don't know, after this is ended, give me 15, 20 minutes.
Yeah, no problem.
Yeah, if that's all right.
Sure.
Yeah, all right, nice one, Sean.
So yeah, thanks for filling out the poll for us. I'm assuming there's sort of things coming in.
I think so. 9 out of 13 have voted.
And if you don't mind using the chat box just to say something you found good, something you didn't find good, and a suggestion, that would be super helpful.
Yeah, and thank you very much, everyone, for listening. Yeah, that's difficult doing this. And so, sorry for the speeding up and slowing down and all that.
We'll give you all a bit of time to write your comments, and then feel free to leave the meeting when you want to. Yeah, thanks again for coming on, and I will keep you informed as to future webinars that we'll be hosting.